Not yet.
No.
Okay. How about now?
Yes.
Yeah.
Yes,
Yes,
visible.
it is.
Okay. All right. So let's start the discussion, right? So yesterday we learned about what is, sorry, I have a different brush. Yeah, so we learned about what is DevOps and why do we use it, right? We also learned how it works together with our existing SDLC models. So how it works together with waterfall
Agile.
and agile, right? How you can have a complete transformation to DevOps, or you can pick and choose between various DevOps tools and technologies to complement what you are already doing in waterfall or in agile. All right. So today we are going to concentrate on continuous integration. Okay, so we will talk about what is continuous integration, how does it work, what are the benefits, and what are the use cases for it, right? So continuous integration, actually by definition, it means that continuously subject your code or your product to validation, right? So that means whenever the code changes, even so slightly, you validate it, that the code change is not breaking something which already exists in the project, right? Or not introducing any new bugs. Okay, so what used to happen in older projects, or maybe some projects right now, this happens, maybe you have seen this in your experience. So what happens is that each uh, let's say this is a project, right? And these are uh, let's say this is your project code base, right? And in the project code base you have your project files, right? Let's say the project is C based, so A.C and B.C and C.C, for example. These are the files which are part of your project, and all the development teams together modify these files to achieve the functionality that is required by the customer. Okay, now let's say there are three features that are need to be developed: feature one, feature two, feature three. Hmm? And let's say developer one is working on feature one, developer two is working on feature two, and developer three is working on implementing feature three. Okay, now they will generally, so, in the traditional way of working, they will not start working at the same code base. For example, developer one can create their own branch and start working on that. Developer two can create their own copy of the project and start working there, and developer three may also start working um, um, in isolation, right? Because they don't want to their work to have any adverse impact on the other developers' work. So developer one continues to develop their feature, developer two continues to develop their feature, and developer three continues to develop their feature, right? And there comes a time when all these features that are developed have to be integrated together, right? So there is always an activity which is at a certain point in time, which is called as integration, right? And as the name suggests, integration will take care of integrating various developers' work together into a common code base. Okay, so developer one, let's say, for example, their code base is merged to the branch, the running branch, right? And then developer two's work, let's say, it is merged into the running branch. Now, because developer one and developer two were working in isolation, their code base was not in sync, right? So when developer two merges their change, well, there could be some sort of problems, on the product. So for example, because some changes introduced by developer one, developer two's changes are not working fine, or developer two's changes are working but with unexpected behavior, right? So some changes have been done and it's making the product work in a not so ideal way, right? So integration is not so straightforward. You have to then fix those bugs and make extra changes on your existing code base, so and then make a new integration attempt, right? So this is a integration activity which is generally done, for example, every week or every 2 weeks or twice a week, some point in time. And this is when all the developers works comes together and sit on the same branch, sits together. But then whenever the change is merged back to the main or running branches, how do you validate that the final result after merging these developers changes is good, right? There is no adverse impact on the project. So that is done by running your test cycles, right? So if developer one's changes break something, then the test cycle will fail. If developer two's changes break something, then test cycle will fail, right? So this is integration is a point in time activity to merge all the developers work together. But this does not go with the philosophy of DevOps where you are releasing each change, right? In DevOps, you want to release each change, right? You want to deploy whatever you change in the project, it should be immediately deployed. Now, if you make a change and then wait for integration and then find bugs in integration and then fix those bugs and then again do a test, then again do a second round of integration, well, you are never ready to release the change, right? So DevOps suggests that you should do a continuous integration. So don't wait for any point in time to validate your project. Continuously validate the project. So that's called as continuous integration. Okay. So what does that mean? That means that if this is a project code base and these are the files in the code base, and then there are developers, right? And all the developers work on the same copy of the project. Okay. And as soon as they make a change, let's say developer A makes a change, then that change is immediately subjected to validation, right? That change is immediately subjected to validation. So you perform a long validation cycle. And this may consist of doing a quick compilation of a project to see if your project is compiling properly and this new change has not broken anything. Then you can also do maybe code check or static code analysis. Yeah, whatever you want to whatever checks you want to perform on your code. So you can perform that to just to ensure that the code is written well, right? And then you can also see, okay, let's do a unit test as well to see if whatever was defined in the test is passing. So whatever code change is coming is passing. Yeah, you can perform more checks. For example, you can run a full system check and say, okay, let's see if entire system is working with this new change coming in. So every change that goes into the repository is validated, right? This is called continuous integration. So you don't wait for a point in time, and that's when you validate your changes in your entire product uh, as a whole. You check it every time the code base changes. Okay, and it's a very good practice to have continuous integration in your project, and that will ensure that your project is always healthy and is fit for consumption by other developers or other partners. Okay, so how do we set up this continuous validation? Well, also continuous integration. To set up continuous integration, you have four textbook requirements, four main requirements that you need to have. Without those, the you will not be able to achieve continuous integration. So first requirement is that you should have a version control system. or also known as software configuration management systems. You should have one of these. Why is this required? So a version control system allows you to track and identify all the changes made into your project, right? So each change that is made to your project, maybe somebody changed file A.C, developer 2 changed file C.C. Why the change was made, who made the change, what went in the change, when was the change made, everything can be tracked by version control system, right? Because each change is a separate entity here in this continuous integration. So there has to be a solution which allows the system to track each change, and that is provided by the version control system. Hmm? Then second is you need to have automated builds, right? The builds should not be, or compilation. When I say build, it should be compilation. So it should not be a, when you have a project and when you want to generate the final deployable package, and you want to compile your project together to create a one big executable file. It should not be that someone has to sit and write some commands, then give some inputs, click certain buttons, and then the compilation happens, right? So you should be using some sort of build systems to perform automated build. So for example, you can use CMake or Make, right? Or Maven or Gradle or whatever. There are various choices available in the market. So some sort of build system is used to perform automated builds. And by automated, I means unattended builds. Okay. Then third thing is you should have automated tests, right? You should ensure that your test can be executed unattended, right? So you have some scripts written or some framework being used to run your tests. Okay. Finally, you should have a continuous integration server. Guys, can you please mute if you don't wish to speak? There is some noise coming. So you should have a continuous integration server, also known as orchestration or orchestrator, which actually does all this, right? Which actually allows you to integrate your version control systems with your compilation and with your unit test and static code analysis and all that. And it creates this entire pipeline from end to end. Okay. This is provided by some sort of solution, right? For example, here we have some solutions like Jenkins, Bamboo, or now you have very modern technologies like container-based CI/CD pipelines like Tecton or Argo CD. Some sort of solution for orchestrating this pipeline. So to summarize, we need four things to be able to successfully create this continuous integration pipeline. You need to have a version control system. You need to have automated builds. You need to have automated tests, and you need to have CI servers or on orchestrator, right? These are four basic requirements. Then you can build on top of it as well, right? So you can say, I also want static code analysis. So let's throw in some Sonar Cube there, right? I also want my code coverage. So let's throw in some Jacoco there, right? Or with Python, I can use PyTest and coverage modules, right? So you can add on top of this, but these are the basic requirements. Okay. So now in this discussion, we are going to talk about these two things, the version control and the CI server. All right. So what is a version control system? Have you guys, is there anyone in the participants who does not know what is a version control system or a software configuration management system? Is there anyone in the participants who does not know this?
Version control we know, but not software control management.
Oh, these are same. This is just a synonym here.
Okay.
All right. So you know version control systems, and how many of you guys know Git as a version control system?
I know.
Okay. Okay. How many don't know?
Sorry.
No. Yeah. My question was the other way around. How many of you don't know what is Git?
Don't know.
Okay. One person. Maybe let me check the chat. No responses on chat. Okay. So version control system is a system which allows you to track each and every change in your project, right? So if there is a project and it has, many project files, in the project, and the files are being changed, somebody's adding some content, somebody's deleting some content, somebody's updating some content. So these changes that are being made to the project files is tracked, right? And it is recorded. So by recording, it means like, who made the change, what was the change, why was the change made, when was it made. All that information is captured when this change is made, so that later when we have to track back and see if something went bad and how could we have prevented it, or what's the reason that builds are failing now. If you want to see, we can always go back and see who made certain changes in the project, right? And that can be done by using a version control system. Okay. The most popular version control system right now in the world is Git. Almost all the projects who use version control system and who have no compulsion to use any other version control system are using Git. Otherwise, there are teams who are using SVN, and there are teams who are still using ClearCase. But yeah, I think these tools are now dying down. Whenever somebody wants to use a version control system, they directly go to Git. Okay. So Git is an open source, okay, free open source software, and is available for free, and is the most popular software right now. Okay. Nobody owns Git. Git is a public property. Right now, nobody has bought it. I don't know. Maybe somebody will buy it from Linus Torvalds, but right till now, it is free. Okay. And it is a distributed version control system. So what does that mean? What is distributed version control system? So this means that the entire repository or the entire project files, along with the history and the metadata, or you can say the database of the project, is distributed among all the users. Let's say you have a central server which stores your project files, right? So you have a Git server, for example, which stores your project files, right? So a Git server can store multiple projects. So there could be project one, project two, and each project will have its own files, right? Each project have its own files. And the Git server will store the project files. Also, it will store the complete metadata about those projects, right? So complete history and other information and configuration, for example. Right, so everything will be stored in this project, in this storage. This such sort of thing is called a repository. So on Git server, you store your repositories, and repository is nothing but your project files and your project metadata, right? So this is one repository, and there could be multiple repositories on a Git server, right? Examples of Git server, for example, GitHub or Bitbucket, GitLab. right? So these are the solutions that are available for Git Server, and the Git Server does nothing but host a Git repository. Git repository contains your project files and the history of the files. Now, if a developer has to work on the project, so let's say this is a developer, and this is a developer machine, and this is also another developer's machine, and if they have to work on this project, what they do is they copy over the entire repository. So this is called as cloning of the repository. They clone the entire repository. So when they clone the repository, they get the project files, they get the files, and they get complete history, or I would say metadata about the project. Okay, so whatever changes have been made to this project file since the beginning of time, everything will be also downloaded on this machine. So your files and your metadata is available here. Same will happen for other project as well, right? Or other developer as well. When they have to work on this project, they will clone the repository, right? So they will get their files and metadata. Okay, and when they have these files and the metadata, then they can make changes to the project. So they can edit the files, right? They can update the files, right? They can perform CRUD operations on the files. Okay, and since the entire metadata is also available on these machines locally, well, they don't need to be actively have a networking connection with the central server. They don't need to be connected to the central server. All changes can be made locally here. So complete repository is now distributed among the developers. Okay, that's why it is known as a distributed version control system. Now, this sounds like a dedicated system, right? You are not connected, and the complete repository is downloaded. It is a huge overhead. The developer does not need everything on the system. They just need access to one file and edit file and done with it. But there are a lot of advantages of doing this. Okay, a lot of advantages. Maybe you guys can suggest some advantages that you think are offered by a distributed version control system like Git. Anyone wants to suggest some advantages here?
If Hi Amit, Mridul here.
Yep. Hi.
Uh, if there is a new developer coming on the project and he used to study the project what earlier have has done, so he can study the full project and then he start to work.
Mm-hmm. Yes. So you can say that complete history of the project is available on local machine. Is that what you mean?
Yes, yes.
Yeah.
Shravanti here.
Hi.
Hi, actually, it reduces the cost and even it saves the time too.
How does it reduce the cost and save the time?
We're just copying it. We are not developing anything.
But the end goal is to develop, right? End goal is to make the changes. Or
Even we have the all the references now. We can use them instead of implementing new one. It is too difficult. Editing and updating it becomes easy.
yeah, okay, agreed.
With Ravi here. So I think the major advantage is reliability.
Can you explain reliability?
Reliability means, I mean, if something goes wrong with one set of data, then the other set of data is available for the
Yeah.
usage.
So you are saying that there is duplicate data available or there's replication.
Yeah.
Yeah, correct. That's correct.
I guess disaster
Hi.
management is the main thing.
Can you please repeat?
Disaster management. If
Oh,
center repository lost somehow, then we can easily recover from distributed system.
yes. So disaster recovery, which results from the replication. Yes, good.
Hi, Amit Umesh here.
Hi, Umesh.
So I think main advantage of Git is code merging is easy if you're working
Yes.
on big team,
hmm So you are
and
saying branch management.
yes, branch management.
So yeah, that comes from Git. Yeah, branches.
Hi Amit, Anisha here.
hmm Hi.
My point is also on the similar lines. What I want to say is it's reversible. Something goes wrong with the new versions, it's always reversible. We can revert back to the older version.
But that is possible in all version control systems.
Uh, it's easily accessible through Git,
Okay. Yep, makes sense.
and it's documented in real time.
Yeah, that is also true. Yes. One biggest advantage which no one mentioned is because everything is available locally on your system. Well, it is any operations that you perform are quite fast. So you make a commit, it happens like this. If you make a merge, it just happens like this. You want to create a branch, well, you can create a branch very quickly, right? So all the operations become fast, right? And also you lose the dependency. There is no dependency on the central server. So if you lose the connectivity here to the central server, doesn't matter. You have everything here, right? So this is the advantage of using a distributed version control system, right? But there are some trade-offs as well. For example, if you are not connected to the central server, then whatever changes you make here, whatever updates you are making to these project files, well, they are still local to your repository. You cannot share it with developer B here. It is still on your or developer A's desktop or workstation, right? Then to be able to share it with developer B, you need to have a connectivity to the central server. And that's what is required. So when you want to share your code back to the repository where other people are accessing the repository, then you have to get the connectivity and push it. Otherwise, still you are working on your own feature and you don't care about others, then you can do it in isolation on your own, right? So this is something, it's not a drawback, but it's something that you have to fall back to. You eventually do need connectivity back here. Okay. Another drawback is that if your repository size is huge, let's say, for example, if there is a badly planned project and everything is being dumped in Git repositories. For example, I have seen many teams dumping their PowerPoint presentations, their tools binaries, their test reports, everything in a Git repository, and the repository swells up to a size of to the tune of, for example, 15 GBs, one repository of 15 GB size. And because it contains the history of all the files and the files themselves, it reaches this size very quickly if you store binaries there. Now, if another developer joins in and he wants to work on the project, well, he or she has to download the entire 15 GB of data. There is no other way around it, right? So if he just has to modify one text file, well, it's not possible unless you have all the data downloaded to your system. Okay, that is one more disadvantage here. But this disadvantage comes mostly on the bad planning of the repositories. Generally, you should not have repositories more than maybe process restrictions or incompetency, they uh, end up swelling in size, right? And if that happens, then this goes for a toss. This process goes for a toss. Okay, so this is distributed version control system, and Git is an example for this, right? So how does it help our continuous integration pipeline? Well, each change that comes from the developer is tracked, and as soon as a change comes, Git can then inform an outside system or an external system by doing a trigger or by executing a hook, and an outside system can make use of this trigger to run certain tasks. So for example, you can say anytime a code is committed or pushed to my repository, or anytime a code is merged to my repository, then validate that code, do the validation, because I want to do continuous integration. So you can use Git to integrate with external continuous integration solutions, for example, Jenkins, right? So let me go to a new page here. So if you have a Git repository, yes, you have your project files and your metadata and everything. As soon as a commit or a change arrives, well, it triggers your CI pipeline, right? And the CI pipeline can be defined in Jenkins. Just give me one sec, guys. I don't know why many people are calling me today. Okay, so it triggers the your validation pipeline, which you can define in Jenkins or any other tool, right? And in the pipeline, you can define what you want to do. So you want to maybe compile the project, or you want to maybe test the project, or do a static code analysis on the project. So many things you can do in the pipelines. Okay, so before going to the pipelines, let's understand what is Jenkins. Now, question to everyone: how many of you do not know Jenkins?
I don't know about Jenkins.
Okay, so just one person who does not know Jenkins.
There are 10 to 15 years.
I
Others are
don't.
raising hands.
Oh, see, the problem is I am not looking at the chat. Okay, so many people do not know Jenkins, right? All right, so let me talk about it a little bit. So Jenkins is also a free and open source software, right? People say that there is nothing as free lunch in this world, right? But when you come to DevOps and when you see that these tools available for free, you really wonder, is that really true? But yeah, so Jenkins is free and open source software which you can use to orchestrate your tasks, right? When I say orchestrate, what do I mean? So let's open up a browser, and I want to find an interesting image. Let's say an orchestra. Yeah. Okay, you guys all know what is this, right? This is an orchestra. Can you guys see my screen?
Yes, yes.
Okay,
Yes.
so this is called an orchestra. And in this orchestra, you see there are various people doing their thing, which is playing an instrument. So you can see here many people are playing violin on this side of the orchestra. And then there are people here who are playing flute, right? And then there are people here who are playing some sort of trombone or some other wind instrument. Then there are people who are playing the trumpet, and then there someone else playing something. Yeah, and then there are guys who are playing these bass guitars and some normal guitars and many kinds of instruments. Now the people here, or this lady here who we can see, maybe if I zoom in, this lady can only play violin, right? She cannot play this bass guitar, or she cannot play this flute. She can only play violin. Similarly, this person here can only play a bass guitar. They cannot play violin or any other instrument, right? But still, they are all able to work together and produce music. How is that possible? How are they in sync, and how are they able to interact with each other to produce a very well defined symphony or very well defined music? Any idea? What is one thing that is connecting them together?
Coordination.
Yes,
The
but how are they?
guy standing in the middle is guiding all the.
Yep. So this guy is taking care of instructing when someone should start playing their instrument, right? So you can see his hands waving around. You start playing now, you stop, and you start playing. You go higher, you go lower, things like that. This guy is called an orchestrator. Okay, he's an orchestrator, or sometimes it's also called as master or orchestra master or whatever. But he's an orchestrator, and he is orchestrating all these musicians to play their instruments or do their thing whenever he calls them to do. Okay, and he is the one bringing all of them together to create a symphony. Now, Jenkins also plays similar roles. Okay, if we go to our diagram here, uh, 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 our diagram here. So when we say that we want to do continuous integration, what we mean is essentially whenever a code changes, we want to compile it, we want to run static code analysis, we want to run the unit test, system test, code coverage, many things that we want to do on our code. Now, all those things are done by individual tools, right? For example, compilation will be done by Make or Maven or CMake, some tool, right? Testing will be done by PyTest or JUnit or whatever, JMeter for performance testing. There is a specific tool for a specific need here. And static code analysis will be done by, for example, SonarQube. Code coverage will be done by Jacoco or whichever tool you want to use. Now, there are all these tools available to perform these tasks. Now, what Jenkins does is Jenkins understands how to talk to these tools. Jenkins understands how to call Maven to run a compilation, or talk to SonarQube to run static code analysis, or talk to JUnit to run unit test, or talk to Jacoco to run coverage. Okay, what it does is it integrates them together, just like this guy integrates all these tools together. When you define your pipeline, or when you say what I want to do after the code is merged, you define, okay, Jenkins first call the compiler, then call the test executioner, then call my static code analysis, then call my coverage report analysis. And Jenkins will call all these tools one by one, passing data among each other, and finally running this validation task on your entire changed code base. So that's what Jenkins does. Jenkins itself does not have any of its own understanding. If you just install vanilla Jenkins and say, hey, compile my code, it doesn't know what you want to do, because it does not have the underlying tool which will do the compilation. Similarly, if you say, hey, I installed Jenkins, but it is not testing anything, well, it will not do, because it will integrate with an existing testing tool to implement your pipeline. So Jenkins is an orchestrator. It does not do anything on its own. It just integrates all these tools together to perform their own individual task. But what Jenkins does is it identifies a sequence of the tasks. It ensures the data is transferred correctly from one task to another task, and all the reports are available, all the notifications are sent, all the inputs are gathered from the user or from whichever place, and create a defined end-to-end pipeline. So that's what Jenkins does. Jenkins is written in Java. Okay, and that means you can run Jenkins on any machine, on Windows, on Linux, Macs, on Raspberry Pis, any kind of hardware. Wherever Java is running, you can run Jenkins, and it's freely available. You can install Jenkins just like that and use it, right? So unfortunately, we do not have much time to have a demonstration on Jenkins and Git and how they all work together. but maybe tomorrow, if you find some time, we will also take a look at that. Okay, so at the end, you have your Git repository, and developers make changes to the Git repository, and then Git triggers something in Jenkins, and then Jenkins calls all these tools one by one, calls Maven to do compilation, SonarQube to do static code analysis, and also it can pass on data from one stage to another stage here. Call JUnit to do unit test, and call PyTest to do your system test. And then also, if something fails, for example, if static code analysis fails, Jenkins can also send a notification back to the developer saying, whatever changes you made has made the project to fail the validation. So your code is bad, please fix it. If unit test fails, then it can again send a notification, maybe to a manager, and say, see what your team is doing, whatever changes you are making is a bad quality, so take care of this. You don't want to release bad code to your customer, right? Your reputation is at stake. So you can send notifications as well to the customers, and notifications can be of any kind. You can send emails, you can send uh, uh, your chat messages, you can send SMS, provided you have the infrastructure for this, right? As I said, Jenkins will work with all these external tools. It will not have its own intelligence. So you can define your notifications, how the notifications are sent. You can also scale up Jenkins, so you can have different kind of configuration environments. For example, if you want to run a compilation on a Linux machine, and then static code analysis on a Windows machine, and system test on a cluster of machines, you can do that. Okay, so that's all I had. Any questions?
Hi Amit, I had one question.
Mm-hmm.
As you said that developer commits the changes in a Git and Git triggers the Jenkins. So let's suppose, is there any error or any something bad happened in Jenkins, or some, let's say, some test fields. So is that changes will be committed, or it will be revoked to the, it will be get back to the developer?
Mhm. Okay, so this is where your branching strategy plays. In Git, you can create multiple branches, right? You may have heard of branches, right? So for example, you can have a branch like called as master branch. Okay, and this is your main branch. Okay, this is a branch where all the stable code lives. Now, whenever a developer makes a change, well, they don't make a change directly to the master branch. They create their own temporary branch and makes a change here. And whenever this change is made, well, Git will trigger Jenkins validation. And if this change is bad change, test fails or the validation fails, same will be notified to the developer. And same also will be marked against this change, right? So this change will be marked as bad, for example. Now, the developer will not be able to merge this change back to the master on your stable branch. Okay, so all changes made by the developers are made in their own short-lived branches. And once the changes are marked, unless the changes are marked as good by your CI pipeline, they are not allowed to merge the change to the stable branch like master, or maybe a release branch or something like that. So the change just stays there, and then this branch can be deleted or whatever, and the change just goes away. It is not part of your master branch.
Okay, thanks.
Mhm.
Yeah, Amit, I have a question regarding for this DevOps job role position. If we are able to develop the scripts, shall we develop the scripts by using the PySpark scripts? Using PySpark?
I did not understand the question. Which scripts are you talking about?
Yeah, PySpark. Shall we develop the scripts using PySpark for the DevOps?
What kind of scripts, for example? Do you have some example in mind?
Like unit test. Yesterday you told that we have to write some scripts with using
Ah,
some
okay.
programming languages, like right?
Okay. So
Yeah.
generally it depends what is the use case, right? For example, if you are on big data and data analysis domain and you are doing some CI there, you may write your scripts in R, right? And you may use Spark with Python there also. Okay, so but if you are just writing uh, something for, let's say, embedded systems, then you will use Python vanilla Python to write your scripts to interact with multiple systems, right? If you're writing something on web technologies, then you may write some scripts using C# or something like that and get your job done. So it depends on the domain,
Okay.
and then the requirement from the domains, right?
Mhm.
Generally I have found that Python is sufficient to write your automation, and generally the automation is mostly around having two systems work together. So you write a script to maybe copy file from one system to another system, or do some cleanup after a job is done, something like that. So vanilla Python is more than enough.
Okay, man. Thank you.
Hmm.
Amit, maybe like what is CA server? I mean, is it the DevOps service that we get, for example, from Microsoft, or I mean,
So
how I mean,
CI server is an orchestrator which can allow you to create the pipelines by integrating all these components and all these tools which are part of your pipeline, which you want you to be part of your pipeline. So Jenkins is something, a very famous CI server, because you can install it anywhere and use it on premise also. Now you have managed CI services also. For example, AWS has AWS code build and code deploy. So they have their own DevOps tools. Then Azure DevOps has lot of tools around DevOps as well. So there you have some build capabilities and CI capabilities. GitLab has fully furnished end-to-end uh, software solutions, starting from your Git repository up to your deployment. So GitLab also is something is there. So you can use based on your use cases. There are many solutions available on this now. Jenkins is a still a popular solution because you can install it in premise, no cost involved, and it is very I would say general purpose. So it integrates with any kind of tools, and can be used in any kind of use cases.
so I mean, can I say Azure DevOps, because I mean Azure DevOps is a kind of Jenkins which has the inbuilt pipeline creation for integration.
I wouldn't call it as a Jenkins. I would call it as a DevOps solution. One more CI solution, for example, not as
Okay.
a Jenkins, but as another CI solution.
Okay.
Yeah.
And the scripts varies based on the CI server, or would
Uh,
that be common, or how
yes.
it is?
So for example, in Jenkins, you may write scripts in Groovy, right?
Okay.
On your AWS code build, generally you write your scripts in YAML,
Okay.
right? In Azure DevOps, I'm not sure, but I think YAML would be used. On Tecton, you write your YAML files, right? So it depends what kind of tool you are using. So yeah, there could be some different um, scripting technologies required.
Okay. And I mean, maybe I might be, I mean, kind of mixing up the things, but one more question around the workflows in GitHub, for example.
Mhm.
So the workflows are basically the GitHub. Can we see there is also another CI solution where it has its own workflows or actions?
Yes, so GitHub has its own workflows. For example, these GitHub has GitHub Actions. You can also create customized webhooks on GitHub and trigger external solutions, right? To integrate for your CI pipeline. So you can use that as well. In GitLab, for example, it is much more advanced. So you have inbuilt hooks and inbuilt CI server as well. So you can directly integrate from your code itself, your CI server.
Okay. And when we utilize Jenkins, so we should have separate version control system, which should be communicating with Jenkins solution. Is my understanding correct?
Separate means for why do you? I mean, what kind of separation?
So I'm trying to understand from GitHub for example, because GitHub has its own version control management or version control system, and
So GitHub
along
is
with that,
basically Git. It uses Git for version control. Yeah. So GitHub is a hosting service, a repository hosting service primarily. Yeah. Okay. Please go ahead.
yeah. So I mean, I'm trying to see like version control system is separate from what Jenkins is, right?
Exactly. Yes.
Yeah, okay. So that's where the GitHub will be placed as basically it's a kind of CI solution, which you just Git as the VCS.
Yes.
Okay, that's it, Amit. Thank you.
Any more questions before we wrap up?
Amit, can you brief us about the what is CherryPick?
So CherryPick is a way to export a specific change from one branch to another branch, right? For example, as I said here, you have a long running branch, which is the most stable branch, and the developers can create their own branches, right? To implement their features. Now, this developer, for example, this developer A has created a branch to make their changes, and let's say developer B also has made a branch to make their changes. Now, this particular commit implements a change which is very important to developer B also. So what developer B can do, it can take this particular change and only this change and put it in their branch, so that they have all the changes made here in their branch also without actually merging the branches, and then continue to build on top of it. So this activity is called CherryPick.
So developer A, the branch of developer A is different from the master branch, I guess.
Yes. Well, you can cherry pick from master branch also. You can cherry pick from any branch. This is just an example which I just mentioned.
Okay, thank you.
Yeah. Okay, so looks like we do not have any more questions. So tomorrow we are going to talk about, maybe if possible, we will see the demonstration of Git and Jenkins, how they are integrated together. And then we will talk about how do we deliver applications developed like this using Docker in a containerized manner, and also a very, very brief overview of Kubernetes. So I'm sure you guys must have heard about this. Some of you are already working with it, but for those who are new, this could be a good brief introduction. Okay. All right, then thank you for your time today, and I will see you tomorrow. Okay.
Thank you.
Please take
Thank
care.
you.
Bye.
Thank you.
Stay safe.
Thank you. Thank you.
Thank you.
Thank you.
Thank you.
Thank you, Amit.
Thank you. Bye.
Thank you.
Thank you, Amit. Bye. Have a good day.
Thank you.